Right, now we're going to continue on with lesson 10.2. We're going to combine a translation and a reflection. So what you see here is a reflection. When your leading coefficient is negative, your function reflects over the x-axis. For instance, a sine function, which would usually go like, oh goodness, sorry about that, which would usually go like this, when you reflect it, it just goes the opposite direction. So that right there is because of the negative leading coefficient. So that's all that really changes. So let's go ahead and set up everything. So my A term is -2. B is 2/3. This means I am shifting right by pi/2. So our period is going to be 2π/b. So instead of 2π divided by 2/3, I'm going to multiply by 3/2. And that gives me 6π/2, which is in fact 3π. That's my period. So if I get all my points, I'm going to go from 0 to 3π. Halfway is going to be 3π/2. Quarter way is going to be 3π/4. And 3/4 away is going to be, let's see, 9π/6, which would be 3π/2. Nope. Let me look at that. 9π/4. Sorry about that. 9π/4. So those are my 5 points, but I need to take into account that I am going to the right by π/2. So I'm adding π/2 to my points. So that first point is going to be π/2, and then 3/4 plus π/2 is 2/4, 5π/4. 3π/2 plus π/2 is going to be 4π/2. 9π/4 plus π/2 is 11π/4. And then 3π plus π/2 is 7π/2. So those are my 5 points. Okay, that gives a pretty good estimation of where I am going. The blue marks are a shift right of π/2, and if I had rooms, I would label them with these measurements, right? So we're starting here for sine. Let's see, A is -2, so 2, -2. I'm going to go down first, remember, because it's negative, and then up, and then back. So there we go. Tangent, remember tangent is a little bit different. So I have A is -3. This is up 5. B is 1. So my period is pi. And if we remember, we go positive and negative. We go from -π/2 to positive π/2, and then 0. And then we're going to have -π/4, positive π/4. We just split it up into 5 points. So the only thing the up 5 does for us is shifts the midline up 5. 1, 2, 3, 4, 5. So that's our midline. Our period, -π/2. Our halfway point, So we have our asymptotes. This should go up. A is -3, so 1, 2, 3. 1, 2, 3. So that's where our halfway point is going to be. It's the amplitude, right? So now I can draw my curve through the origin, but it's not really the origin anymore. Cool. I just realized that's wrong. It's negative, so we're going to do it in blue highlighter. Sorry about that. I hope you caught it. Maybe you were paying closer attention. So that's where we're going. Okay. So the blue fuzzy marker is right. The red pen is wrong. Okay. Glass elevator. You are standing 120 feet from the base of a 260-foot building. You watch your friend go down the side of the building in a glass elevator. Write and graph a model that gives your friend's distance d in feet from the top of the building as a function of the angle of elevation. So going down in a glass elevator. So this is a strange type question. What we see in that triangle on the previous slide is theta. I've got, it says there, you and friend, 120 feet, and this one's going to be 260 minus d. That's the picture you see in the previous slide, where up there is d. Crazy, I know. So, we don't know the hypotenuse from what we have here, but I do know that tangent theta is opposite over adjacent, where opposite is 260 minus d over 120. That's just your definition of tangent. Cool? So, I'm just going to use this side and that side. I know tan theta is 260 minus d over 120. No, I'm not going to do that. I'm going to multiply both sides by 120. And I get 120 tan theta is 260 minus d. I can go ahead and subtract 260 from both sides, and I get 120 tan theta minus 260 equals negative d. Therefore, d equals negative 120 tan theta minus 260. Actually, it would be like this. So if I took away, I wrote d, I put b. That's hilarious. If I distributed that negative, I get 120 tan theta plus 260. So that's my function. That's pretty cool. Cool. Now I'm going to graph that. So I know d equals negative 120 tan theta plus 260. So A is negative 120, B is 1, my period is pi, we're going up 260, so I don't know, 90, 180, 270, I have a midline there. My amplitude is 120, so 270 minus 120. About there. That's my midline. My period is pi. So pi over 2. Negative pi over 2. That one doesn't matter though, right? Pi over 4 and 0. So here it's negative, and my asymptote. So my graph is going to look something like this. Okay, we really don't care about this part, but I know that I've got a curve, and then it's going to be, in fact, we don't care about this part either. Let me just redraw this part. It's awful, I know, but that really is about how your tangent is going to look. I would assume it'd be more curved if it were drawn better, more like that, but my drawing isn't all that good. Okay, all right, let's try some guided practice. So graph the function. A is -1, B is 1. We're going left, pi over 2. So my period is 2 pi. So I always write out my 5 points. And I'm going to subtract pi over 2. So I'm subtracting pi over 2. So my first point is going to be negative pi over 2. My second point is 0, pi over 2, pi, and 3 pi over 2. You may have been able to do that in your head. Not so much for me. So negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. This is a cosine function. Normally that starts at the top. So I have 1 and -1. Since it normally starts at the top and I'm reflected, we're actually going to start at the bottom. And notice I'm putting all the points. And then it's easy just to connect the dots. Here I have A is -3, B is 1/2. My period is 2 pi over 1/2, which is 4 pi, up 2. Cool, I don't have to go left or right. That's pretty exciting. So my 5 points. Halfway is 2 pi, quarter is pi, 3/4 is 3 pi. So plot those. This is a sine function. It's negative. A is 1, 2, 3, 1, 2, 3. So I'm going to start here, go down, up, up, and down. So I do my minimum first and then my maximum. Oh, I left the answer here. I'm sorry. I didn't mean to do that. So A is -1, B is 2. We're going down 1. It's tangent, so tangent is pi over B. So pi over 2. So my period's pi over 2. That means my asymptote is at negative pi over 4 and pi over 4. And my halfway point is pi over 8 and negative pi over 8. We went down 1, so this is my midline. So that means we're going to go, A is 1. So I actually would want to, oh, that shouldn't be erased, sorry. Yep, that goes right there, and this one goes right down here. And then midline That's how we get our curve. What if, in example 6, how does the model change if you are standing 150 feet from a building that is 400 feet tall? If I go back and look at that example, this is 150, and this would be 400 minus d. So tangent theta is opposite over adjacent. So 150 tan theta minus 400 equals negative d. D is negative 150 tan theta plus 400. What else can I tell you about this? Oh, I didn't see the answer right there. That's pretty funny. The graph is shifted 400 units up instead of 260, so I didn't have to do all of that math. I could have just traded that out. It's fun to go through the math, though. All right, good work. That's all we got.